Right. There are some important graphs in a photoelectric effect experiment. Okay. Before we go into graphs, I need to clarify with you again about this one. Okay. The difference in intensity and frequency. What's the difference between intensity and frequency? Okay. Just have a look. Intensity. What is intensity? Intensity means different brightness of light. Different brightness. Like you see this one, intensity of light. All these are same orange light. Orange light, different intensity. Like this one, intensity just 10%. You can see very dim. Intensity 30%, brighter. 60% intensity or brightness. 60% brightness. You can say 10% brightness, 30% brightness, 60% brightness, 100% brightness. See, this is the different intensity lah. Okay. See, less particle, more and more particle. You see the brightness. I will talk about this later. I just want to tell you that intensity is about brightness of light. Brightness of light. Okay, different brightness. Okay. Now, how about frequency? Frequency is related to wavelength, isn't it? Because frequency is velocity over wavelength. So frequency is related to wavelength. Different frequency will have different wavelength. Different frequency will result in different wavelength. So different wavelength means different type of light. You have red light at wavelength 700, violet light, wavelength at 400, orange light, okay, wavelength at 600, green light, wavelength at 530, yellow light, wavelength at 580 nanometer. I put all at same intensity. Yeah, you see all these, they have same intensity. So intensity, it just means the brightness of light. Frequency or wavelength. Frequency or wavelength means different type of light. Okay. All right. Okay. So that's it. So again, frequency is different type of light. Intensity is different brightness of light. Okay. So first thing here, first of all, the first condition is I fix the frequency. I fix the frequency means I fix the type. I use the same type lah. I use maybe just frequency. Okay, I just write here. I fix the type of light. Intensity is the brightness. Yeah, intensity is. So now I change the brightness. I change the brightness of light, but I fix the type of light. I just use one type of light. Maybe I just use the blue light. Okay, or I just fix the type of light lah. Yeah, one type of light. Metal surface also I fix. So the work function, yeah, metal surface is related to the work function, or the threshold, or we can say I fix the threshold frequency and the threshold wavelength. I fix all that. Right? I fix. So, okay. Back to classical physics and quantum physics. Classical physics, he relate the intensity to energy. Still remember that? Intensity is related to energy. Okay? Because according to the formula for intensity, it is power over area. And power is actually energy over time. Energy over time. So that's why intensity is related to the energy. Okay, for classical physics, he's saying that the higher the intensity, the higher the energy. The higher the intensity of light, the higher the energy. So the higher the intensity, the higher the energy. But that does not happen in photoelectric effect. Maybe I can summarize here. Intensity is in classical physics. Intensity is about the brightness of light. Brightness, maybe we can think of it that way. Yeah. Maybe now I fix red light. I just use red light. Okay. So this is the dim light, and this is the the bright red light. Okay, this is the dim red, the dim one, and this is the bright one. Yeah, he's saying this one has more, the dim one has less energy, the bright one has more energy, and he think that the energy, he think that the classical physics energy is related to the amplitude of wave, isn't it? Classical physics is about wave. You think the light as a wave, whereas quantum physics thinks the light as in the form of particles. Okay, so in the form of wave, energy, still remember the formula for energy? Again, energy formula here the energy formula, last time in the wave, mechanical wave or simple harmonic motion, you learn energy is half m omega square amplitude square. This is the amplitude. Okay, amplitude. So that means if high energy, they will have high amplitude. They will have high amplitude. High amplitude. So dim light, low energy means small amplitude. Why he think that the dim light has a small amplitude? Maybe like that. Okay, wave. But for bright light has more energy, means bigger amplitude. Bigger amplitude. Yeah. See that? Small amplitude, big amplitude. Okay. Because you think the higher the intensity, the higher the energy, the higher the amplitude. Okay, that's the classical physics. But for modern physics, intensity is not about energy. Intensity is about the number of photon, and that's the actual case. Intensity is about number of photon. He see the light in the form of particles. So about the low energy, if low intensity, what happened? Let's write this down. This one, just now the dim one means low intensity, bright one means high intensity. Low intensity means low energy, high intensity means high energy. This is what they think lah, classical physics. But this is not correct. This is not correct. But the quantum physics one is the correct one. Okay, so high intensity means okay, I should write like that. The high intensity means more number of photons. The higher the intensity, more number of incident photon. It's actually, intensity is number of photons over time times area. It's actually, the more the intensity, the more number of photons. So what it means here is, I just compare between low intensity and high intensity. Okay, just now also I compare low intensity and high intensity. I take again for quantum physics. Let's talk about the dim light. Okay, the dim light. For quantum physics, the dim light, how we look at dim light and how we look at bright light. Okay, for bright light, this is the bright light. Okay, this is the low intensity and this is the high intensity. This is the dim light. This is the dim red light with low energy. No, not low energy. This is a bright red light. Okay, bright light. Okay, last time classical physics is saying that dim light has low energy, small amplitude. Bright light has big, high energy, high amplitude. But for quantum physics, it's not about the amplitude. It's not about energy. It is about number of photons. Dim light, low intensity. Low intensity means the light. Low intensity means the light has less. Low intensity means less number of photons. Less number of photons. Maybe just 2. Less number of photons. The n is less. N is less. N is the number of photons. But for the bright light means a lot of photons. A lot of photons going. Going to there. A lot of photons. This is bright light. A lot of photons. but still each photon has same energy. Okay, the energy are still equal. No matter it's dim light or bright light, the energy still the same. I mean energy for each photon. Yeah, energy for each photon is still the same. Energy for each photon still the same. The size of the photon still the same, but the number of photons for dim light, less photon, bright light, more photons. That's it. Look at this one. Look at look at about the intensity. Yeah, intensity. Look again. Low. Yeah, you see. Low intensity like this one, 20%. 20% light, 20% intensity, only have 2 photon. You see that? 50% intensity has, you see, more photons. More photons compared to the 20%. About the 100% intensity, 100% intensity, yeah, look at this one. 100% intensity, you have even more photons. You see that? You have even more photons. So many photons. Okay, that one, less photon. Okay, the 100% intensity, even more photons. Wow, there are so many photons. Okay, so many photons. For the 20%, intensity, only have 2. You see, you have 2. For 100% intensity, you have how many photons? You count by yourself. Yeah, so many. Yeah, just like snow. So many photons. This is 100% intensity. Okay. Okay. So look again. Right. Okay. So for quantum physics, the light intensity is about the number of photons. The higher the intensity means the more the number of photons. But energy for each photon still the same. Okay. So what happens if you use higher intensity of light? For example, like the photoelectric experiment. If you use dim light, what happens is what I explained. If I use dim light, let's say I use a dim light. If let's say I just use a dim light, maybe intensity just 10%. Intensity just 10%. Dim light. Maybe I just use the dim blue light. So dim blue light maybe only have 2 photon. Only have 2 photon. 2 photons incident. So how many electron will be ejected? If 2 photons coming, 1 photon eject 1 electron, isn't it? 1 photon only eject 1 electron. Okay, 1 photon only eject 1 electron. So if 2 photons coming, how many electron will be ejected? Only there will be only 2 electron ejected. Okay, then there will be 2 electron ejected. Okay, 2 electron will be ejected. So 2 electron will be ejected. So the current will record how many reading? If only 2 electron ejected, means this is the photocurrent. This is what we call photocurrent. Because it's by photoelectron. This is the photoelectron ejected, and they reach the anode, become the photocurrent. So this current will record the reading of positive 2 electron. Sorry again, I shouldn't draw. This is will record the current of 2 positive 2 electron. Okay, the photocurrent is positive 2 electron. So if I use that's the, we can say if all the 2 electron reach the anode, this will record the saturation current, the maximum current, or we can say the saturation current. The saturation current. So if intensity 20%, if intensity 10%, that means it's just like 2 photons coming, 2 photoelectron ejected, So the current also only record 2 electron, positive 2 electron. I mean the saturation current is 2 electron. If the intensity is let's say your intensity is 30%, maybe there are 5 photons coming. 5 photons coming. So how many electrons will be ejected? If you got 5 photons coming, means got 5 electron ejected. Then the current will be, the saturation current will be also more, positive 5 electron. If you have 100% intensity, very bright light. Now you are using a bright blue light. A bright blue light. You have if 100% intensity means have photons. Maybe you have 20 photons coming. You have 20 photons coming. You can eject 20 electron. When to eject 20 electron, the current also record positive 20 electron saturation current. So what I can say here is, the higher the intensity, the more the photons, the more of the incident photons, the more the photoelectron ejected, the higher the saturation current. The higher the saturation current. But what I can say is the frequency never change. The kinetic energy is still the same. The kinetic energy of each electron is still the same, because the intensity is only about the number of, the higher intensity means the more the number of photons, means 20 photon already. You have 20 photon coming. 20 photon coming. More intensity means more photon. More photon coming. So more electron ejected. How to draw 20 electron here ejected? 20 electron ejected. There'll be 20 electron flowing in the circuit. 20 electron flowing in the circuit. So there'll be, the current will be positive 20 electron, because current is a positive charge. So you've got 20 electron flowing in the circuit, there'll be more current. So all the other things never change lah. Like the stopping potential no change. Only the current change. Okay? Understand? So in a nutshell, I can say intensity affect the saturation current. That's the main thing here. The main thing here is the intensity only affects saturation current, the I maximum. Okay, so you see, intensity is about the number of photons. It's not about the energy. It's not about the electron ejected, more energetic. No, it's not about that. It's not about that. It's about the number of photons. More photons coming means more electron ejected. More electron ejected means more current recorded in the galvanometer. More current means higher saturation current. Okay? So intensity is proportional for quantum physics. Intensity is proportional to the number of incident photons. So the higher the intensity means the more the number of incident photons. Higher number of photoelectrons ejected, more, and the photoelectric current, saturation current, this I maximum means saturation current, will be more. So I can say like that. So if you just take let's say a one-time intensity, the saturation current is I maximum. If two-time intensity means you have, maybe, so I can say like that. One-time intensity means maybe you have only have 100 photons coming, but two-time intensity means you have 200 photons. 100 photons means the current will record 100 electron ejected, the I maximum. Sorry, I should write over where. If less intensity, 100 photons, means the saturation current recorded, positive 10 electron. It recorded positive 10 electron current. Because got 100 photon can eject 100 electron. Can eject 100 electron. But with 200 photons, 2 times the intensity, 200 photons, mean it can eject 200 electron. Can eject 200 electron means got 200 electron flowing in the circuit. 200 electron flowing in the circuit, 2 times the current, 2 times saturation current. Okay, 100 photon eject 100 electron. 200 photon mean eject 200 electron. So the saturation current double. All right, double the intensity. You double the intensity, you will also double the saturation current. But the stopping potential is fixed. You see, this one is fixed because why? Because I fixed the frequency. You see that? Because I fixed the frequency. Because stopping potential only depend on it's actually about the Kmax. Yeah, because we know about Kmax, which we will learn about later. Yeah, how the stopping potential will change. How will it change? So voltage doesn't change. Yeah, the stopping potential doesn't change because it depends on the EVS, isn't it? And Kmax depend on the this formula. Kmax depend on the formula. Yeah, so Kmax. So we can say stopping potential does not depend on intensity. Stopping potential depend on Kmax. So stopping potential only depend on Kmax, and Kmax only depend on the energy of photon. Only depend on energy photon, which is the frequency and the work function. Okay. So so the Kmax, so the stopping potential only depend on Kmax, which is depend on frequency and the work function. So stopping potential only depend on these two. Stopping potential only depend on frequency and also only depend on the metal. Depend on frequency and also depend on metal. Okay. It depends on the frequency and also depend on the type of metal used. Stopping potential. So it does not depend on intensity. So in the stopping potential still equal. Okay. So now how about this graph? This one is about photocurrent with intensity. So the higher the intensity, the higher the saturation current. This is the saturation current. 1 time intensity means 1 times the saturation current. If 2 times intensity means you have more photons coming. More photons coming means can eject more electron, can eject more photoelectron, more photocurrent. Okay, so the current is proportional to the intensity. Okay, so that's it for this video. Okay, let's continue to the next one about the frequency and also about the work function, how it affects the stopping potential. Thank you. And once again, I just want to say that, conclude that intensity is about the number of photons. It's not about the energy. It's not about the energy. If you thought intensity is proportional to the energy, then it will affect the stopping potential. You see that? If classical physics is correct, the higher the intensity, the higher the energy of the electron ejected, then the stopping potential will also change. But in photoelectric effect, the stopping potential doesn't change. It means that the intensity doesn't affect the energy. It doesn't affect the energy. It doesn't affect the energy. Yeah, you see that? Intensity in classical physics, intensity proportional to the energy. So it affect the energy. It will affect the Kmax. It will affect the stopping potential. But in reality, photoelectric effect, the stopping potential is fixed, which means that it does not change the energy. Yeah, the intensity does not change the energy. Okay, intensity is only about it only change the current. It only change the saturation current, but stopping potential doesn't change. So intensity does not affect the energy. Intensity is about the number of photons. More number of photons coming. More photons coming means more electron will be ejected, and the galvanometer will eject more current because there are more electron flowing already. After more electron ejected, there'll be more current flowing in the circuit because more electron flow in the circuit. Okay, thank you, and let's move on to the next video.